started the chapter Applications of Integral, in which we learned how to find the area under the curve using integration. Right? So today I'll take up some more problems. Yes. The question is, find the area of the region bounded by y square equals 9x, x equals 2, x equals 4 and the x-axis in the first quadrant. Yes. First we will identify the curves involved in the question, then we will draw the figure. Yes. Y square equals 9x. It is of the form y square equals 4ax. Yes. It represents a parabola with vertex at origin and axis along x-axis, positive x-axis, right? X equals 2 will be a straight line parallel to y-axis drawn at x equal to 2. Similarly, x equal to 4 will be a line parallel to y-axis drawn at x equal to 4. Right? So let's draw the rough sketch. Yes. Let this be the Cartesian plane. This is x-axis, this is y-axis, this is origin. Curve is y square equals 9x. It is a parabola with vertex at origin and symmetrical about x-axis. It will open towards right. Right? So it will be like this. Right? Now x equal to 2. Let this be 2 and this be 4. Now x equal to 2 will be a line drawn parallel to y-axis from this point. So this is the line x equals 2 and from here this is the line x equals 4. Now, we are to find the area of the region bounded by this curve, these two lines and the x-axis in the first quadrant. Right? So one thing is clear, that the region lies in the first quadrant, that is in this part. So, region bounded by the curve. This is the curve in the first quadrant. The line x equal to 2, x equal to 4 and the x-axis. So the enclosed region is this, right? Let us name this region as A, B, C, D. So we are to find the area of the region A, B, C, D. So area region ABCD will be equal to integral from 2 to 4. Yes, I want y of parabola. Yes, equation of parabola is y square equals 9x. So from here, y of parabola will be square root of 9x. That is, y will be equal to 3 root x. Right? So I'll put this value here. So it will be 3 root x dx. Now I need to compute this integral. So in order to compute the area of the region ABCD, I'll consider a thin vertical strip here, right? Let this point be Px comma y, and let the width of the strip be dx. Length of the strip will be this. It is the distance of the point P from x-axis, which will be equal to the y coordinate. So it is y. So area of this strip is y dx. Right? Now I have to find out the area of this region. So I have to decide the limits of the integration. As I have considered a vertical strip, and to cover this area, the strip will move from 2 to 4. Look at this, x-axis, 2 to 4. So limits of integration will be 2 to 4. So area region ABCD is equal to integral y dx from 2 to 4. And yes, this point P lies on the parabola. So here y will be of parabola. Now 3 is constant, so I take this outside the operator. Integral 2 to 4, and this can be written as x raised to the power 1 by 2 dx. Now integral is x raised to the power 1 by 2 plus 1, increase the power by 1 unit and divide by with the increased power within the limit 2 to 4. So here I'll get 3. This is x raised to the power 3 by 2 over 3 by 2 within the limit 2 to 4. So it will be 3 2 by 3 into x raised to the power 3 by 2 within the limit 2 to 4. Now this is equals to the value at the upper limit minus value at the lower limit. So first I'll compute the value at the upper limit. It's 2 by 3, replace x with 4, minus value at the lower limit, replace x with 2. Yes, I take the common factor 2 by 3 outside. So I'll get 3 into 2 by 3, and I can write this as 4 raised to the power 3 raised to the power 1 by 2, minus similarly here 2 raised to the power 3 raised to the power 1 by 2. Yes, so it is square root of 64 minus square root of 8. So which is 2 into 8 minus 2 root 2. That is 16 minus 4 root 2. So area region ABCD is 16 minus 4 root 2 square units. Next question is, find the area of the region bounded by the curve y equals x square and the line y equals 4. Yes, first we will draw the figure, and for that we need to identify the curves. Yes, the curve is y equals x square, that is x square equal to y. It is of the form x square equals 4ay. In class 11th, you learned that it represents a parabola with vertex at origin and it is symmetrical about positive y-axis. That means this parabola will open upwards, right? Y equal to 4 is a line parallel to x-axis drawn at the point 0, 4. Yes, so let's draw the figure. X square equal to y represents a parabola with vertex at origin and symmetrical about y-axis, that is the parabola will open upwards. Right? Vertex is at this point. Next we have line y equal to 4. Let on y-axis, let this be the point 4. That is the coordinates of the points will be 0, 4. So y equal to 4 will be a line drawn at this point parallel to x-axis. So this will be the line y equals 4. Now in order to get the area of this region, what I'll do? I'll consider a horizontal strip here. Right? Now, this point P with coordinates x, y lies on the parabola. This width of the strip will be dy. Length of the strip will be equal to x. So, area of the strip in this region will be x dy. Now, to find out this area, I'll integrate this, and limits of integration will be, yes, the strip will move from this point O to this point M. The coordinates of the point O are 0, 0. As I have considered a horizontal strip, so limits of integration will be from 0 to 4. See the y coordinates. So area MBOM will be integral x dy from 0 to 4, and required area will be double of this. So required area is given by this. Now the point x, y lies on the parabola. So this x will be of parabola, right? Now equation of the parabola was x square equals y. So this implies x of parabola will be square root of y. So I put this value here. So I'll get 2 into integral 0 to 4. X of parabola is root y. Right? Yes. This can be written as y raised to the power 1 by 2. Now we need to compute this integral. So it will be 2 into integral will be y raised to the power 3 by 2 over 3 by 2 within the limits 0 to 4. That is 2 into 2 by 3 into y raised to the power 3 by 2 within the limits 0 to 4. Now this is value of this at the upper limit minus value at the lower limit. So first I'll compute the value at the upper limit. It's 2 by 3, replace y with 4 minus value at the lower limit. When I replace y with 0, I'll get 0. So lower limit is 0. So I'll get here 2 by 3. This can be written as 4 raised to the power 3 raised to the power 1 by 2. So it's 2 into 2 by 3 into cube of 4 is 64. Raised to the power half means square root of 64. So it's 4 by 3 into 8. That is 32 by 3 square units. So required area is 32 over 3 square units. Next question is, find the area of the smaller part of the circle x square plus y square equals a square cut off by the line x equals a over root 2. First we shall draw the figure. Yes, x square plus y square equals a square represents a circle with center at origin, that is at 0, 0 and radius a. Right? So we have drawn a circle with center at origin. Right? So as the radius of the circle is a units. So if this be the point A, then its coordinates will be a, 0. Because this is the radius, it is a units. And this point lies on x-axis, so its coordinates will be a, 0. This point B will have coordinates 0, a. This point C will have coordinates minus a, 0. And this point D will have coordinates 0, minus a. Right? X equal to a over root 2 is a line parallel to y-axis. So here we have marked these 4 points A, B, C, D on the circle, right? Now I have to draw the line x equals a over root 2. This distance is a. Let this be a by 2. Then a over root 2 will be greater than a by 2. So it will be somewhere here, right? So let this point be a over root 2 comma 0, right? Now x equal to a over root 2 will be a line parallel to y-axis drawn at this point. So let the line be this, parallel to y-axis. So this is the line. X equals a over root 2. Now we are to find the area of the smaller part of the circular region cut off by the line x equals a over root 2. Yes, this is the circular region. This line x equals a over root 2 cut this circular region in 2 parts, this part and this part. We are to find out the area of the smaller part. That means we have to find the area of this part. That is MPAQM, this whole part, right? Now by symmetry, area of this part will be equal to area of this part. So can I say that this whole area will be equal to twice of area AMPA. So now I need to compute area of this region, right? So for that, I'll consider a vertical strip in this region, right? This is the vertical strip. Width of the strip will be dx, right? Let this point P x comma y lies on the circle. So length of the strip will be equal to the y coordinate of the point. So length of the strip will be y and here y will be of circle. Now I need to find out the area of this region. So strip will move from M to A. So I'll integrate this and limits of integration will be, yes, the coordinates of the point M are a over root 2 comma 0 and coordinates of the point A are a comma 0. Strip will move from M to A and as it is a vertical strip, see the x coordinates of M and A. So limits of integration will be from a over root 2 to a, right? So required area is double of this. So now I need to compute this integral. Yes. So first I need y of circle. Yes, equation of circle is x square plus y square equals a square. So from here y will be equal to square root of a square minus x square. So y of circle is this. I'll put this value here. So required area will be twice of definite integral from a over root 2 to a. Y of circle is square root of a square minus x square and this dx. Now this integral is x by 2 into root a square minus x square plus a square over 2 sine inverse x by a within the limits a over root 2 to a. Now this will be equal to value of this at the upper limit minus value of this at the lower limit. Yes, so first I'll compute the value at the upper limit. So I'll replace x with a. When I replace x with a, here I'll get a by 2 and this will become 0. So this term will get vanished. So, and here I'll get a square over 2 sine inverse a by a, right? This is the value at the upper limit minus value at the lower limit. So here I'll get a over 2 root 2. This is a square minus a square by 2 plus a square over 2 sine inverse a over root 2 and this a, right? So here I'll get a square over 2 sine inverse 1 minus, this is the value at the lower limit, minus a over 2 root 2, and this will give you a over root 2 plus a square by 2, and here I'll get sine inverse 1 over root 2. So this is twice of a square by 2 into sine inverse 1 is pi by 2 minus, this is a square over 4 plus a square over 2 into sine inverse 1 by root 2 is pi by 4. So this is twice of a square into pi over 4 minus a square over 4 minus a square pi over 8, right? So that will give you, I take the LCM, it's 8, 2a square pi minus 2a square minus a square pi. That will give you, I combine these two, a square pi minus 2a square over 8. So from here it's 2, I take the common factor a square outside, here I'll get pi minus 2 over 8. That will give you pi minus 2 into a square over 4 square units. So required area is